In this video, I'm going to tell you everything about the biggest installation I've ever done with Mainframe, and the hope is by explaining how I built it, installed it, and operated it, it'll inspire any Mainframe users to go about and build their own installations. And that's kind of the interesting thing about Mainframe, because among many things, it's actually kind of acts like a light installation controller. By actually customizing the LED side of things, you can actually build your own light installations because the controller side, which is Mainframe, is already taken care of. And then the LED side is really not that hard to work with, and I'll try to go over everything you need to know for that. And when I say this was the biggest installation I've ever done, I really mean it, because this installation was 2,860 LEDs total with 2 mainframes. And the crazy thing is it's been about 3 years since I've been working on this project, and for the first 2.5 years, I swear I've only ever tried Mainframe with 120 LEDs max. And that's all I kind of expected Mainframe to do. But since using Mainframe out in the public more and customers asking directly, like, how can I make big installations with Mainframe, I've decided to kind of push in that direction a bit more. And with that came a lot of challenges that I didn't expect, honestly. Another thing that made this installation kind of interesting is the music was actually performed by a DJ. And Mainframe being a MIDI visualizer, I'll have to show you guys how I ended up doing that connection. And now let's dive into the design and the setup of the installation. Hold on. If you're new to the world of Mainframe, I suggest you take a look at our video on MAINFRAME-B, which is the first product in the Mainframe line of audiovisual controllers. In a nutshell, Mainframe's trying to solve a lot of the problems experienced by lighting professionals today, and Mainframe-B is the very first step in this, what I consider will be a very long journey of trying to develop a new and novel lighting controller. Also, if you've seen that video, you should take a look at our video on splitters and how to get more LEDs out of your Mainframe, because in this video we'll be building on a lot of the concepts introduced in that other video. There'll be links to both videos in the description. Okay, now let's begin. Before I dive into the details, I'm just going to give you a quick overview of the system. Now, every Mainframe setup has 3 parts. Firstly, you have the MIDI source. This is whatever you have that actually generates the MIDI notes that Mainframe will then visualize. In my case, I'm using Ableton. Next, you have the Mainframe controller, and in this setup, I have 2 of them. Mainframe receives MIDI data in 2 ways. First, you have USB MIDI, or you have 5-pin MIDI. And then finally, you have the LEDs. And to go from Mainframe to the LEDs, we're using a standard red, white, and green LED cable. In this setup, since I have 2 mainframes, one of the mainframes goes to the big cube, and the other mainframe goes to all the smaller cubes. One thing I should mention is that the DC power jack that's on the Mainframe controller is what actually sends 5 volts and ground to the LEDs like that. And that will be important once I describe the details. And let's dive into that. We're going to start with the MIDI source. Okay, as the MIDI source, typically what I use is Ableton. And it's pretty easy to bring your laptop to an event, set it up on the table next to the DJ. What I also have is the Ableton Push connected to Ableton as well. This is strictly not necessary, but I find it's a little more, makes it a little more usable instead of just kind of clicking everything with the mouse on Ableton. And connected to my laptop running Ableton, I have a USB hub. Specifically, it is a powered hub. And the reason why I have a powered USB hub is when you have too many mainframes connected, since they draw power for the user interface, the lights and stuff, there's potential for you to be drawing too much power from your USB port. Whereas if you have a powered USB hub, that becomes not a concern at all. So I always recommend you use that if you have multiple mainframes connected. And from this hub, I have 2 USB cables going to the 2 mainframes, which I'm using for the system. And I'll explain the mainframe side in a bit. Let me show you what the Ableton project looks like. Here I have an Ableton project I just set up because the Ableton project I used for that show is on a different computer. So now there are 2 mainframes in this setup, and each of them has its own group of external instruments, which is this instrument right here. And basically what it is actually just how you send MIDI out to an external instrument. So when you click one of those, you see right here, external instrument, I have MIDI to mainframe selected here. You can only send to 1 channel per external instrument, so I have 3 external instruments here. Channel 1 going to zone 1, channel 2 going to zone 2 on mainframe, and then channel 3 going to channel 3 on mainframe. And I have the channels set up that way on the mainframe side as well. Under each of these external instruments, I have clips, which basically have just a very simple just loop right here. I'll show you. So right here, for example, I have just quarter notes. Channel 2, I have just one long note that goes on for the whole bar. And then channel 3, I have a bunch of 16th notes. As this song is being played, basically you just play this Ableton project and it's going through these clips here and sending the data to mainframe. What you do then is you actually tap the tempo to match the music that's being played right now. And I find this actually works pretty well because unless the DJ is changing the tempo all the time, then it doesn't work very well. But I found, at least in the few shows I've been to and I did this, it worked pretty well. Because there's also these two buttons here, which you could nudge it back and forth. So in case, let's say the tempo is correct, but now the kick drum, let's say, is not lining up perfectly, you can actually nudge this forward or back to have it line up nicely. And that, along with the tapping the tempo, I find it works pretty well. And where this gets kind of fun is during the show, I actually have the flexibility to create new clips here. For example, I could create new clips here, then I could actually modify it a bit, like that. And basically you just kind of keep on making clips like this throughout the night to now experiment with the lights. As long as you're still maintaining this, this 4/4 timing, I find you could play around with the MIDI notes quite a bit. And then with that, you're kind of experimenting with the lights because I could set the MIDI notes here, then go to mainframe, change the parameter values, and actually experiment with the lights and try to make the lights match what's happening with the music, which becomes its own sort of fun sort of activity and a performance in its own way. How this also gets kind of interesting is in each of these clips, you could add CC envelopes. So now if you don't know already, all of Mainframe's parameters can be automated through MIDI CC envelopes. So what I do is I go down to this clip menu here, go to envelopes, select MIDI control, then here I could select the MIDI CC numbers. Now MIDI CC number 1 modulation wheel is hue. So I click that, and you could actually get kind of interesting results here. If you go into draw mode, whenever there's actually a note, you could have it this specific color like that. And you can actually get really cool results this way, because let's say this is hue, then I could go into, I think 14 is decay. So you could have the lights kind of stay on longer when the note's being played, then quickly die out when there's no note, stay on when there's another note, and then quickly die out when there's no note. So you could actually now get even more flexibility with how the lights end up displaying by playing with CC automation. And that actually pretty much explains the Ableton side of things. What we'll do is we'll go back and I'll explain the mainframe side. Okay, so now we have two mainframes, and that is because we have the big cube to power as well as the small cubes. We have one USB-C cable and then another USB-C cable going to the second mainframe. So mainframe is actually powered by USB-C. So that's all you really need connected in order to actually power the mainframe controller board. So now one mainframe is actually powered from the external 5 volts. The other mainframe is not, and I'll explain why in a moment. Typically you have the little red, green, and white cable coming from mainframe going to the LEDs. The reason why this setup is actually very different compared to the previous ones and the challenge I was facing is these little cables are not good at very long runs. And one of the reasons is if you're drawing quite a bit of power from those little cables, the voltage drop is too high. So then not enough voltage reaches the actual lights, and then they don't really function. So that means I wasn't actually able to use the little red, green, and white cables. Since the big cube and everything else was hung quite far away from where the mainframes were set up, I needed a different solution, because anything I tried with the little cables, it wasn't good enough for such a long run. So actually how I solved that issue is I used an Ethernet cable. I have one Ethernet cable, a 10-meter Ethernet cable going from where the mainframes are set up to the big cube, which has a bit of a hub, and I'll explain that in a moment. So what I have here is a little tiny signal booster. It takes the data signal and the ground from each mainframe, boosts it a bit, and then sends it down the Ethernet cable. This signal booster was needed because the mainframes themselves weren't able to give a strong enough signal to go through the Ethernet cable 10 meters of it, so it's received properly on the other end. So I made this little signal booster. This signal booster was a bit of a challenge to find out, because originally I just tried to send the mainframes through the Ethernet cable and that just didn't work. It was just performance was a bit poor. So I had to, like, night before the show, quickly create this little signal booster, and it ended up working pretty fine. What I'm planning to do is actually make this little signal booster its own sort of small board. So if you did want to run it through Ethernet cable and make larger networks, you could just get this little tiny board here, which will allow you to do that. Because otherwise, if you just have small connections, like, you know, just on your desk or something, or even a small show where you don't need such a long run, this is not really needed. It will work fine without that. But otherwise, for long networks, this signal booster was needed. Now back to this power connection. The reason why this mainframe has power is because this signal booster needs power. So I actually routed the power to go from the signal booster to power this board here. This mainframe does not need that external 5-volt power. It only needs the USB power just to run, because all that's needed on the side at the end of the Ethernet cable is the data signal, the green wire, and then ground, of course, because on that end it's being powered separately, and I'll explain. On the LED side, I actually have the cube attached to a white board, and it's actually suspended to the ceiling using aircraft cable. I've actually never suspended anything like that before, so it definitely was an interesting experience. There's actually a lot going on the very top of the LED cube that's being suspended, and I'll explain what I have set up there. So actually I have two splitters, splitter number 1 and splitter number 2. From the Ethernet, we're getting 2 data signals from the 2 mainframes. Two data signals from the 2 mainframes. Signal number 1 and then signal number 2. And we're receiving ground as well, because you always need the grounds connected in order for things to work properly. Now, as I mentioned, power is not being received through the Ethernet cable, but instead what I have is actually a separate power supply, which is actually just a computer, power supply that I have mounted to the top of the board. So the reason why I chose a computer power supply is because they can provide quite a bit of power, and they're quite stable as well. Typically for LEDs, you end up using the LED power supplies that you could just buy online, but I just didn't have time to order it and wait for it. So I just used the computer power supply I have at home. So I actually have a little connector, that's the motherboard connector basically, the female end of it, so it connects to the male end from the computer power supply. First of all, the grounds are connected, and then we actually have the power coming from this connector to these splitters right here. And then I should also note, it's actually quite important to say that I actually had also a power cord going to the top of that cube separately, which is powering the computer power supply. And then finally the LEDs. The reason I have 2 splitters is because we have 2 mainframes, and then we want them to power 2 separate things. One of them is the big cube, and another one is the smaller cubes. Let me talk about the big cube. Now the big cube is basically just 5 LED grids being duplicated from this splitter. What I have here is all these 3, so the power, ground, and data are all being sent from that splitter to each of these grids. So pretty straightforward having this is duplication. If you watch the video on the splitters, you'll understand the concept. And now on the other splitter, I have something kind of interesting. So I have 4 smaller cubes. Okay, let's draw a cube. Oops, I could do better than that. Yeah, good enough. Okay, so here's a cube. And we have 4 of them. So now the cube, the sides aren't duplicated. Each 64 LED side of each cube is its own. Basically, it forms a long chain of 320 LEDs into this entire cube. Now, where it gets interesting is instead of cables, I actually use the Christmas lights as the cables, because the Christmas lights are basically a cable. It just has little lights that go along the way. So it does add to the overall count of LEDs. But it actually, you could power stuff through the Christmas lights as well. I would not recommend you powering like very bright LED strips through the Christmas lights, but since the cubes aren't drawing very much power because they're quite dim, the Christmas lights functioned perfectly fine. And that's something to think about if you want to try out the Christmas lights, is they can actually act as cables as well, and it could give a kind of a cool effect where you could create almost like pulsating lights coming from mainframe through the crystal lights into the cube and things like that. And I must also say that typically, at least currently, the max number of LEDs that could be connected to mainframe is 320, which is this cube. I've increased the max a bit for this show just to kind of test out how it performed. And it looked like it performed pretty well. So that means I might actually increase the overall limit of mainframe's max number of LEDs, just with a bit more testing. So let's draw this out. So basically, I have the crystal lights going to each of the cubes, coming from this splitter like so. Now, like the cable, each crystal light is able to send the data, ground, and power to these cubes. And that's, it turned out to be kind of messy, but that's okay. Good enough. So that actually pretty much covers the entire system. I will admit, at first glance, it maybe does seem a bit complicated. And if you have a bit of DIY inclination or you have some experience in electronics, it's really not too bad. You should be able to handle this. But if you don't, I don't want you to feel discouraged, because what I plan to do is all these little splitters, power supplies, Ethernet cables, this little booster board, everything, I want to actually create into little accessories. So without any electronics experience, you could go about and build installations like this. So the main reason why I'm showing you this is to kind of give you an idea of what is possible, even with only just 2 mainframes and with a bit of clever duplication and power systems. You could actually get some pretty cool installations. And this is just a start. I really want to make bigger and cooler installations like this, and I plan to make more videos outlining the process so I could inspire you guys to do the same with your mainframes.